Okay, so in part 3b of solving quadratic equations, we're going to look at completing the square. Now, one of the things you're going to need completing the square for, or the concept of completing a square will be when we get into circles. So at some point you're going to write the standard form of a circle. So given an equation looks like this, you're going to use completing the square to write in standard form, and that way you can find the center and the radius of the circle. You're also going to use completing a square when you're given a quadratic function that looks like this, and you're going to rewrite it in this form, so it's called the vertex form, so that way you can find the vertex and the axis of symmetry of a quadratic function, so you can easily graph the parabola. Alright, so in both cases, this does involve completing the square. So one of the handouts that you have in Canvas is completing a square handout. So there are two examples where the coefficient of x squared is 1 here, and the coefficient of x squared is not 1. So we're going to go over these steps, but just look at these examples periodically as you review completing the square. So this is a handout in Canvas that you are going to need at some point, either when you're reviewing this lesson, if you need it, but definitely you're going to have to come back to it when we talk about circles and when we talk about quadratic functions. All right, so as a review though, let's remember the previous lesson, which talked about completing the square. In that case, remember in the previous lesson we were given a binomial that was quadratic in nature, and we wanted to add a term to it, add a constant to it, so that way it became a perfect square trinomial. So for example, if we had x squared plus 10x, let's say, and what I want to know is what do I need to add to this binomial so that way I get a trinomial that is a perfect square trinomial. And remember, if this is a perfect square trinomial, I can factor this as a binomial square. And that's going to be needed in what we're about to do because we're going to use the square root property again in this case. All right, so remember what we did was we took the coefficient of b, so we took the coefficient of b, which in this case is a positive 10, and I divided by 2. So remember, we took the coefficient of b and I divided by 2. 10 divided by 2 is 5. Once I found what the coefficient of b divided by 2 is, I then squared it. And so 5 squared here is 25. So again, we take the coefficient of b, whatever b is here, I divide by 2. Once I divide by 2, I've got to square it. So that's what this says. And so if you go back to this handout, so if you're going to rewrite this binomial as a perfect square trinomial, you're going to add to this binomial, you're going to add this constant, which is b divided by 2 squared. So basically, when I did this example, I took b. Now remember, this is only true if this coefficient of x squared is 1. So we're assuming the coefficient of x squared is 1. So coefficient of x squared has to be 1. So keep that in mind. If it's not 1, then you have to do something else. Okay, so in this case, I get 10 divided by 2 is 5. 5 squared is 25, and then I add 25 here. All right, now, once I do that, this right here should now be a perfect square trinomial, which means I can write it as a square of a binomial. All right, and so if you factor this, you'll notice you do get these binomials being the same thing. So you get x plus 5 times x plus 5. All right, and so this right here becomes x plus 5 squared. Okay, so that's what this says right here. So this says that you're going to take the coefficient of b, you're going to divide by 2, you're going to square it, and then that becomes you can then factor it as a square of a binomial. So it's just x plus b over 2. So remember we got 5 here. So to get 5, you say 10 divided by 2. So b divided by 2. All right. Okay, so let's look at the first example. So number 1, let's suppose we had x squared plus 6x equal 7. So x squared plus 6x equals 7. So remember, whenever we're completing a square, and so let's just go over these steps here. In your handout, you should have had this right here. So it says solving a quadratic equation by completing the square. So to solve this equation by completing the square, we first of all have to go to step 1, which says that if the leading coefficient meaning the coefficient of x squared, that's the leading coefficient, in this case it's 1. If it's not 1, we must divide both sides by that number. So then that would make the coefficient of x squared 1. All right. Then, in this case, we didn't have to do that because the coefficient is already 1. So once we do that, then we isolate the variables on one side and the constant to the other side, which in this case it already is. So the variables on one side, constants on the other. Now I'm going to leave some space here. So I'm going to get x squared plus 6x, leave some space, equal 7. Now, see this right here? That looks like the original right here. Remember the x squared plus 10x? So I'm going to complete the square on this binomial. So to complete the square, this is what the next part says. To complete the square, you're going to add to both sides, because this is an equation. So you're going to add to both sides, which is one side you have to do the other to keep it balanced. So you're going to add half of b squared to both sides. So add the square of half the coefficient of x to both sides of the equation. So basically, you're going to take 6, divide by 2, and then square. So that's 3 squared, which is 9. So I'm going to add, oops. All right, so basically, you're going to add 9 to both sides. And so now, the next part is to factor this trinomial, just like I did this. So this should now be a perfect square trinomial. This should now be a perfect square trinomial. So that's what the next part be. Factor the resulting perfect square trinomial. So basically, if you do this correctly, you should then factor it as x plus and then 3 squared. Now, this should be easy to do going from here to here, because remember how we got it. We took half of 6, which is 3, and I squared it. So this part here, what times itself twice, should be this number here. So that should be half of b. Okay, so this is always going to be, this right here is always going to be half of b. Now, always check yourself, because you could have easily made a mistake. If you FOIL it out, remember, first FOIL, x times x is x squared, the outer is 3x, the inner is 3x. Remember, since these binomials are the same, the inner and the outer should be the same. And then 3 times 3 is 9, so I get x squared plus 6x plus 9, and that's what this was. All right, and so that's going to equal 9 plus 7, which is 16. All right, so now remember in a previous lesson where we used the square root property. Remember the next part here, part 4, is to use the square root property to solve for x. So we're going to use the square root property. So completing a square, when you complete the square, you're going to involve the square root property. Now, the idea of completing squares is going to be extremely important when we get into quadratic functions, graphing quadratic functions, and also finding the center and radius of a circle. So that's going to be important there. Okay, so I get x plus 3 squared equals 16. So now I'm going to take the square root of both sides. Remember, right now I'm squaring this expression, so I got to solve for x, so I got to get rid of the square. The opposite of squaring is just square root of both sides. But remember, when you take the square root of both sides, you get plus or minus. Don't forget that plus or minus. So the square and the square root undo each other. So I get x plus 3 equal plus or minus 4. And now look, this is now a rational number right here. So my solution is going to be rational. So remember, we talked about that in a previous lesson. So that's a rational number. So then once you notice it's a rational number, split into 2 separate expressions or equations. So x plus 3 equal 4, x plus 3 equal a negative 4. And so subtracting 3 from both sides, I get x to be 1. So there's one of your solutions. And over here, subtract 3 from both sides, combine like terms, and I get x to be negative 7. So your solutions are negative 7 comma 1. All right. Number 2. Now remember, you want to do this by completing a square, so always follow directions. All right, number 2, we have x squared minus 6x minus 11 equal 0. So x squared minus 6x minus 11 equal 0. Okay, so remember the first step is to make sure the coefficient of x squared is 1. So coefficient of x squared must be 1. All right, and it is. If it wasn't, we would have to divide everything by that number. All right, now, since it's already 1, the next step, remember, is to get all the variables one side, constants to the other. So, and then we leave some space here between the variables and the right side, the constant on the right side. So I'm going to get x squared minus 6x, leave some space, because you're going to be adding something here, equal 11. So don't forget, this is 11. When you add 11 to both sides, you get 0 plus 11 is 11. Okay, so now let's complete the square in this. So the next step is to complete the square right here. So there are 2 parts. So we're going to add, we're going to take b right here. B is negative 6. So I want you in mind, that's what you're thinking, negative 6. I'm going to divide by 2, and then I'm going to square this. So I get in parentheses negative 3 squared, and that's going to be 9. So this should always be a positive number. Regardless of whether this b over 2 is positive or negative, a positive negative number squared is always going to be positive. So that's why you're adding and not subtracting. So you're adding 9 to both sides. And so now this should be a perfect square trinomial. So we're going to factor this now. So when you factor correctly, the factoring part should be easy. So it's x. Remember, this is 9. The only number times itself twice is 9 is either 3 or a negative 3. And I need this to be, this is what you're always going to put here, I need this to be a negative 3. So x minus 3 squared equal, and then 11 plus 9 is 20. Alright, so now I'm going to rewrite this over. So now I'm going to take the square root of both sides and use the square root property, plus or minus. So the square and the square root undo each other. So I get x minus 3 equal plus or minus the square root of 20. And so I figure out I simplify the square root of 20. So remember, the square root of 20 is the square root of 4 times 5. And so that's going to be the square root of 4 to the square root of 5. And the square root of 2, square root of 4 is 2, so I get 2 square root of 5. So that goes here. So I get x minus 3 equal plus or minus 2 square root of 5. And so now you're going to add 3 to both sides. And so I get, remember, combine like terms, a negative 3 to positive 3 is 0. So I get x to be 3 plus or minus 2 square root of 5. All right, and so remember now this is a, remember a while ago we talked about this being rational. This was rational. Since the square root, since my solution still has a square root in it, this right here is irrational. So that's I'm going to put it here. So this is irrational. So if the radicand is not a perfect square, see this is not a perfect square, then you're going to get irrational solutions. If this were a perfect square, like 16, 25, then you no longer have a square root, so then it would be rational. If it's irrational, this is how you want to write it. You want to write it in compact form. Now, in my math lab, they're probably going to ask you to separate the solutions using commas. So you'd say 3 plus 2 square root of 5, comma, 3 minus 2 square root of 5. All right, so that's that one. All right, number 3. All right, suppose you had, all right, so let's suppose we had x squared minus 5x plus 6 equal 0. So again, the coefficient of x squared is 1, so that's what we wanted. That makes it a little bit easier. And then I'm going to rewrite it so that way the constant's on the other side. That's the next step. So put all the variables on one side, constants on the other. So I'm going to subtract 6 from both sides. And so I get x squared minus 5x equal a negative 6. So make sure you're doing this mathematically correct. So subtract 6, so there should be negative 6, not 6. Negative 6. So you can easily make mistakes along the way, so you got to be careful. Always look at your work. Now remember, in the next step, let me go ahead and just rewrite this part. So the next step, remember, is where you're going to add, and remember, you always add, and you're going to add something to both sides. That's the next step. So that's where you can complete the square. Now this time, you're going to get a fraction. See, in the previous two, those were nice problems because in the previous two, b, negative 6, see, that negative 6 was divisible by 2. Here, the positive 6 was divisible by 2. Here, negative 5 is not divisible by 2. So I'm going to leave it as a fraction, so it's going to look like this. So we're going to take b, negative 5, divide by 2. Now remember, once you divide by 2, you got to square it. And remember, when you square b divided by 2, that should always be a positive number. So a negative 5 halves times a negative 5 halves. So that's what you're thinking. Negative 5 halves times negative 5 halves. A negative times a negative is a positive, so that's a positive 25 over 4. 5 times 5 is 25. 2 times 2 is 4. So this is 25 over 4. So we're going to add 25 over 4 to both sides. That's what we're adding. And so now this right here, now students seem to have trouble when we have a fraction here. So we have a fraction, so they have a little bit of difficulty factoring this, but it's easy to factor. So this is going to be x, and then remember your middle sign's negative, so it'll be minus. Basically all you do is just take this right here and rewrite it. So you're taking b and divide by 2. So this becomes negative 5 halves. Negative 5 halves. So there's your factorization. You can always check yourself. If you want to check this using FOIL. So x times x is x squared. The outer is a negative 5 halves x. The inner is a negative 5 halves x. And the last, a negative times a negative is a positive. 5 halves times 5 halves is what you're thinking of. 5 halves times 5 halves is 25 fourths. And then combine like terms. See right here, you have a negative 5 halves plus another negative 5 halves. And so when I add these, that's going to be a negative 10 halves, which is a negative 5. And that's what you wanted. So negative 10, negative 5 plus negative 5 is negative 10. So negative 5 halves plus negative 5 halves is negative 10 halves. So that's negative 5. And that's what you wanted. All right, and that's going to equal. Now, if you need to use your calculator in this, use your calculator in this. But let's kind of review something from a previous course. Let's remember how to add fractions. So notice I have negative 6 over 1 plus 25 over 4. And the LCD is 4. So I'm going to write two equivalent fractions with 4 as the denominator. So negative 6 over 1 is equivalent to what fraction that has a denominator of 4. So remember what we did was we said 1 times what is 4, so that's 4. Whatever I did to the denominator, I did to the numerator. So negative 6 times 4 is a negative 24. Now over here, the denominators are already the same, so the numerators have to be the same, so I'll just put this as 25. And now since the denominators are the same, I can combine these two fractions. So a negative 24 plus a positive 25 is a positive 1, so I get 1/4. And so I get x minus 5 halves squared equals 1/4. Okay, now here's the next step. So this is where you have to be a little bit careful. I'm going to rewrite this all the way down here. And so I'm going to get x minus 5 halves squared equal 1/4. All right, so I'm going to take the square root of both sides. I'm going to use the square root property. That's the next step. So remember, once you factor this perfect square trinomial, the next step is use the square root property. So I'm going to take the square root of both sides, plus or minus, And so the square root and square root into each other. So I get x minus 5 halves equals plus or minus. Now remember, we're taking the square root of 1/4. The square root of 1/4 is the square root of 1 divided by the square root of 4. And the square root of 1 is 1, the square root of 4 is 2. So this is plus or minus 1/2. All right, now you see how there's no longer a square root, so this is a rational solution. So since it's rational, you're going to split it into two equations. This is rational. It's a rational solution. So I'm going to get x minus 5 halves equals 1/2. X minus 5 halves equals a negative 1/2. And I'm going to add 5 halves to both sides. Combine like terms. This is 0 right here, so I get x and 0 is x. Now 1/2 plus 5 halves is 6 halves, which is just 3. So one of your solutions is 3. Over here, add 5 halves to both sides. Since the denominators are the same here. Since the denominators are the same, I just add their numerators. So x plus 0 is x. A negative 1/2 and a positive 5 halves is a positive 4 halves, which is just 2. So your solutions are 2, 3. So those are your solutions, 2, 3. All right, number 4. Let's do another one with a fraction in it. So let's do one more. X squared plus 3x minus 1 equal 0. Okay, so we remember the coefficient of x squared. We want it to be 1. It is 1. So in every case here, the coefficient was 1. All right, now remember, before we complete the square, we got to make sure that this constant is on the other side. So we got to write it so that way the variable's on one side, constant the other, and leave some space. So I get x squared plus 3x equal 1. All right, so now what you're going to do is at some point to complete the square, you're going to add something to both sides. Oops, did not mean that. So x squared plus 3x equal 1. So at some point, you're going to add something to both sides. All right, so remember the way to do that. So the next step is we're going to take the coefficient of x, we're going to divide it by 2, and then we're going to square it, and we're going to add it to both sides. So the coefficient of x is a positive 3, 3 divided by 2, and then once I do that, I square it. So 3 halves times 3 halves is 9, 3 times 3 is 9, 2 times 2 is 4, so you get 9/4. So remember that's 3 halves times 3 halves. So 3 times 3 is 9, 2 times 2 is 4. So I'm going to add 9/4 to both sides. And so now this should be a perfect square trinomial. So I should be able to factor it as a square of a binomial. And then figuring out what goes in here is going to be a fraction, because we ended up with a fraction here. Should not be difficult, because all it is you're going to say x, and then this sign's positive, so you can say plus. If it was negative, you say minus. It'd be a subtraction. And all you do is just take b and divide by 2. b is 3, divide by 2, and so there's your answer. So really, it's just this right here. So that's a positive 3 halves, so you say plus 3 halves. Now, you can always check yourself. It's a good idea to do that. All right, so FOIL this out, and let's see what we get. We get x times x is x squared. The outer is a positive 3 halves x. The inner, 3 halves times x, is another positive 3 halves x. Remember, these have to be the same since these binomials are the same. And then plus a positive 3 halves times a positive 3 halves. We'd add that right here. A positive 3 halves times a positive 3 halves is a positive 9/4. And so now adding these two, I get 3 halves plus another 3 halves. So 3 halves plus 3 halves is 6 halves, which is 3, and that's what you wanted. You wanted 3x. So this is correct. And now we're going to add these two. So we have 1 plus 9/4. And I'm going to write 1 as 1 over 1. And then we find the LCD. So the LCD is 4. And so we're going to write equivalent fractions. So 1 over 1 is equivalent to what fraction divided by 4? So 1 times 4 is 4. What I do to the denominator, I do to the numerator. So my numerator has to be 4 as well, and that kind of makes sense. 4 over 4 is the same as 1 over 1. Over here, since the denominators are already the same, the numerators have to be the same. And remember, all you do is, if you need to do it just like we did this, you would say 4 times 1 is 4, 9 times 1 is 9. And so I get 13 over 4. So that goes here, 13 over 4. All right, now let's see what we get in this case. All right, so I'm going to go ahead and rewrite this part here. So x plus 3 halves squared equal 13 over 4. Okay, so to get x by itself, remember we're going to use the square root property. It's in that form. So I'm going to take the square root of both sides, plus or minus. And so the square and the square root undo each other, so you get x plus 3 halves equal plus or minus. All right, now let's think about the square root of 13 over 4. All right, square root of 13 over 4. So, just like we did the square root of 1/4 here, we said it would be the square root of the numerator divided by the square root of the denominator. Same idea. So it will be the square root of the numerator divided by the square root of the denominator. Now the denominator, if this 4 is a perfect square, so that's just 2 in the denominator. Square root of 4 is 2. The numerator, I cannot simplify the square root of 13, so it stays square root of 13, and so that goes here. Square root of 13 divided by 2. Now remember, the only number that you're taking the square root of is 13, so don't make this the square root of 13 halves. Be careful. It is not the square root of 13 halves, so don't make that mistake. Okay, it's got to look like this. That's how you have to write it. Now, you see how you have the square root? You still have a square root, so now this is these are irrational solutions. Irrational solutions. So since it's irrational solutions, just like you did in a previous problem, you just wrote it in compact form. So you wrote it as plus or minus. So basically what that means is that you're going to subtract 3 halves on both sides. Combine like terms, you get x equal negative 3 halves plus or minus square root of 13 divided by 2. And there's your answer. Now another way you can write this, just to remind you, see how the denominators are the same? Then you can just write as one fraction. See how these denominators are the same right here? Basically, you could say 4 plus 9 divided by 4, which is 13 over 4. So you could do the same thing here. So you can say negative 3 plus or minus square root of 13 over 2. Now in my math lab, they're going to probably ask you to write this as 2 separate solutions. So you could say a bunch of other things. You could say negative 3 halves plus the square root of 13 over 2, comma, negative 3 halves minus square root of 13 over 2. Or if you want to, you could leave it as one fraction, but just say this: x equal negative 3 plus the square root of 13 all over 2, comma, negative 3 minus square root of 13 all over 2. Alright, so that takes care of this one. Okay, now let's look at a problem where the coefficient of x squared is not 1, just to show you what to do. So this is going to be number 5. So let's suppose we had 2x squared minus 8x plus 6 equal 0. Okay, so let's suppose we had this. Alright, so now this is not going to be that bad because all these numbers here are divisible by 2. So we're going to do one in which they're not all divisible by this coefficient. Okay, so the first thing you're going to do is, since you remember you want this x squared to be 1, so we have to, since right now I'm multiplying by 2, I have to divide all terms by 2, so both sides by 2. So really this is what's happening. Let me go ahead and rewrite this. So remember, you want this to be a 1, so you're going to have to divide both sides by that coefficient. Just like this. What you do one side, you do the other. Okay, now what you need to do, or what you have to think about, is this. Remember in a previous lesson we learned that since this is a monomial right here, I can just write them as separate fractions. So in other words, I can write this as 2x squared divided by 2 minus 8x divided by 2 plus 6 divided by 2 equals 0 divided by 2. So every term, 1, 2, 3, 4, 1, 2, 3, 4, has to be divided by this coefficient of the leading coefficient. Remember, that's called the leading coefficient. So the coefficient of x squared. So 2 over 2 is 1, 8 over 2, negative 8 over 2 is negative 4, positive 6 over 2 is a positive 3. So I get x squared minus 4x plus 3 equal 0. All right, and so now I'm going to complete the square. So now the coefficient of x squared is 1. So now I go to step 2. So step 2 is to bring all the variables to one side, constant to the other. So I get x squared minus 4x equal negative 3. So we're subtracting 3 from both sides. And now remember what you do is you take the coefficient of x, which is negative 4, divided by 2, and you square it. So negative 4 divided by 2 is a negative 2. When I square negative 2, I get a positive 4. So I'm going to add 4 to both sides, just like this. And now I'm going to factor this. So this is now a perfect square trinomial. A perfect square trinomial. And so now you can factor it as a binomial squared. So I can factor this as x minus 2 squared. So remember, it's just this right here. So negative 2, that's what this becomes. You know, again, go back and check yourself. And so negative 3 plus 4 is 1. All right, so now this is the form where I can use the square root property. So I'm going to go ahead and rewrite this. I'm going to take the square root of both sides, plus or minus. Don't forget the plus or minus. The square and the square root undo each other. So I get x minus 2 equal plus or minus. The square root of 1 is 1. So remember, I no longer have a square root, so these are rational solutions. We get rational solutions. And so since I'm going to get rational solutions, I'm going to split it as two equations. So x minus 2 equals 1. X minus 2 equals a negative 1. Add 2 to both sides. One of your solutions is 3. Negative 2 and 2 is 0. X plus 0 is x. The other one, add 2 to both sides. Combine like terms. I get x to be 1. So those are your two solutions. And those are rational solutions. So on my math lab, you would say 3, 1. Or 1, 3. It doesn't matter. Okay, so that's going to take care of, let's go ahead and finish this part here. So that's going to take care of solving quadratic equations by completing the square, where the coefficient of x squared is 1. So in all situations, the coefficient of x squared was 1. The coefficient of x squared is 1, and so on. Now, the last one, the coefficient of x squared was not 1, so we noticed that we had to divide every term by this leading coefficient. Now, this one wasn't that bad because all these numbers here were all divisible by the leading coefficient. All right, so the next lesson, we're going to do several problems, a couple of problems where the leading coefficient is not 1, and all these numbers, all these terms, are not divisible by this leading coefficient. All right, but that's going to take care of this lesson, part 3b.